Phosphorus runoff study shows the importance of stable banks and cover crops. Taking a look at the University of Arkansas and what they're finding. Spring rains are great for flowers and kayakers, but the season also prompts concern about algae blooms causing phosphorus runoff into drinking water sources. Spring steam flow delivery to Beaver Lake has increased over the past 20 years, delivering more nutrients to the reservoir and increasing the risk of algae blooms during the summer, according to analysis of the U.S. Geological Survey data by Irina Tamano, an environmental soil and water science student at the University of UNA. Tamano is a student of the Shannon Spear Assistant Professor of Water Quality in the Department of Crop, Soil, and Environmental Sciences with Arkansas's Agricultural Experiment Station, the research arm of the UNA System Division of Agriculture. Her lab's undergraduate students are conducting studies of watershed as a part of the unofficial partnership with the Beaver Watershed Alliance and the Beaver Water District. They're really interested in knowing this information, Spear said. This was a relatively easy analysis we could do with publicly available data, so we volunteered to jump in and do it. Spear said she had shared information with the groups, and her lab's team has continued to do studies to assist in long-range planning efforts to mitigate phosphorus runoff. Phosphorus runoff can lead to algae blooms in bodies of water, which decreases the available oxygen for aquatic life, also known as eutrophication, as we can find here. And eutrophication is when excess nutrients accumulate in the lake or other body of water, frequently due to runoff from the land that causes dense growth of algae and the death of animal life from lack of oxygen. This was our first cut, but from that we can start building more management and actionable outcomes. Student researchers from Spear's Water Quality Research Team include Jacob Major Jr. and all of the people who are part of this department. And Jacob Major's study highlighted the importance of the creek bank stability, as we can see here. Major study included in his water quality of Richland Creek and the Bush Creek was that sediment-associated phosphorus from bank erosion may serve as a critical downstream phosphorus source to Beaver Lake, and major studies from the higher phosphorus total levels in Richland Creek, but higher dissolved phosphorus in Bush Creek. Richland Creek runs through mostly forest land, about 40% pasture land. Bush Creek runs through mostly pasture land and about 1/3 of forest land. And Spear noted that the higher concentrations of total phosphorus in Rich Creek land could be because of more organic materials like leaf litter in the stream. Soluble reactive phosphorus, however, is more troublesome because the nutrient is more available to create algae bloom downstream. And the major study won the first place for March undergraduates in the student poster competition as well. And they did some research, and they also evaluated the cover crops to mitigate phosphorus runoff on the agricultural fields. A study by the latest experts in Spear's lab showed the importance of cover crops in retaining phosphorus on site. And they analyzed the data on the total flow, total suspended sediment, and total phosphorus concentrations for the runoff events on covered crops and non-covered cotton fields between 213 and 218, the Dumas runoff, while cover crops did not impact the flow from fields. Water runoffs, the total suspended sediment, and total phosphorus concentrations were lower in the runoff from the crop-covered field. So this is an interesting study, and the students really did a good job. And there's different ways to mitigate phosphorus. The best way is to know if you have a high amount of phosphorus, and that is how they were doing it. They tested it. They got samples and saw what was going on. And because of that, they showed the importance of stable banks and cover crops, and it's a good idea for you as well to test your water for high levels of phosphorus.